Tutorial, I will explain to you how to assign oxidation numbers to atoms or ions. So there are some rules that we need to follow. So first of all, in the periodic table, some groups will help you to recognize the oxidation number. So if I have in compounds, and specifically the ionic compounds, so I'm going to give some examples like an ACl, MgBr2, AlF3. It's a combination of metal and non-metal, Be3 and 2, etc. So I'm talking about these metals, what I'm highlighting, and in group 13. In compounds, we can use the periodic table in order to know the oxidation number of these atoms. So for example, in the compound NaCl, Na belongs to group 1. So the oxidation number of Na is positive 1. Therefore, since this is a neutral compound, there is no charge over here, the Cl would be negative 1. Cl changes, but Na constant. So I can rely on the periodic table to find the oxidation number of Na. I'll give you other scenarios where Cl is not negative 1. But let's finish these examples first. MgBr2. So here magnesium belongs to group 2. So the oxidation number of magnesium is positive 2. Now, Br, if I need to calculate and know what's the oxidation number of Br, I can look at the periodic table, it's negative 1, or I can find it. So I know the Mg, and I'm going to say that Br is unknown to me, 2x. The whole thing is equal to 0 because this is a neutral compound, so x would be negative 1. AlF3. Al belongs to group 13. So the oxidation number of Al is 3. And Be belongs to group 2. So the oxidation number of Be is positive 2. As for Cl, Br, and N, in compounds, their oxidation number is not always the same. So we need to solve it. I'll give other examples to explain how to find the oxidation number of these elements. Now we continue. Oxygen, fluorine, and hydrogen, they have fixed number of oxidation number in compounds, and F always in the compound is negative 1 no matter what. Oxygen is always negative 2 except in some cases, I will mention it, and hydrogen is always positive 1 in compounds except in some cases. I have summarized the rules of oxidation number over here. So if any time you have a free element, like the element is coming alone, the oxidation number is always 0. But in a compound, the oxidation number will change. So anytime I have a free element, the oxidation number is 0. Whether it's an element, a symbol with a number, or just a symbol, the oxidation number is always 0. Now, the next thing, if I have an ion, a monoatomic ion, whatever charge written on that ion, that is already the oxidation number. So for example, here, +2 is the oxidation number, and -1 is the oxidation number, and plus +3 is the oxidation number of aluminum. So if we take this example, that's a free element, 0. That's a free element, it's a 0. However, I can see the charge here, so the oxidation number of this ion is +3, and of this ion is -2, +3, and -2. Moving on. Fluorine in the compounds is -1, oxygen in the compounds is -2, hydrogen in the compounds is +1. There are no exceptions for fluorine. There are some exceptions, but I will only cover the exception in the peroxides. Peroxide is a formula like H2O2. In this case, O is -1, not -2. So the oxidation number of O is -1, not -2. And hydrogen is always +1, except when hydrogen is as a hydride, is metal hydride, like for example, coming with group 1, like NaH, LiH, AlH3, KH. In all these cases, the hydrogen oxidation number is -1. Now, the last two rules will help you to determine the oxidation number of what I did not mention in these rules. Like if I have a compound, I talked about O, I talked about F, I talked about H, but I didn't talk about the rest of the elements. So you can use rule 6 and 7 to calculate the oxidation number. And let's start with this example. For example here, which of the following correctly lists the oxidation number of Cl in these two given compounds? So let's take this one, NaClO4. I gave you a rule about O that it is -2. And I gave you a rule about group 1 that it's always +1. But I didn't say anything about Cl because, as I mentioned, Cl can change. So I'm going to assign it as X. And since this compound, there is no charge over here, it means that it is neutral. So the total oxidation number, the sum of the oxidation number of the atoms in this compound is going to be equal to 0. And that's how we solve to find the Cl. Plus A, plus 1, X, and I have 4 oxygen. Each one is -2. Now I'm going to write it equal to 0 because NaClO4 is a neutral compound. So working this out, X would be +7. So in this case, Cl is +7. However, if I take another compound like NaCl, from the periodic table, we know that Na is +1 and we don't know the Cl. So, but this compound overall is neutral. So X is -1. Another example. Which of the following involves reduction? Now, before I move on, I need to tell you why we need to calculate and find the oxidation number for questions like this. So sometimes they get you a question to identify which substance got reduced and which substance got oxidized. So in order to know which one reduced and which one is oxidized, we need to check the change in the oxidation number. So if a substance, for example, I minus changed to I2, is this oxidation or reduction? The oxidation number of I minus is the charge on it. And the oxidation of I2, since this is a free element, it is 0. So from -1 to 0, the oxidation number increased. Therefore, this is an oxidation. So I minus got oxidized. And let's get another example. So for example, I have Fe. I'm going to give another example other than the Fe. Let's say I have Br2 changing to Br minus. As a free element, it is 0. And now it dropped to -1. So the oxidation number reduced. So I will deduce that this is a reduction. Now, let's look at these examples since we need to say which one got reduced and which one got oxidized. So Fe was positive 2 and turned to positive 3. So the oxidation number increased. That's an oxidation. Now, Cr2O7 to minus to Cr3 plus. So let's find out what is the oxidation number of Cr in Cr2O7. This one is positive 3, I can see the charge, but this one, I need to solve it. So 2x, since I don't know the Cr. And why 2x? Because here I have a 2. Plus, I have 7 oxygen, and already the rule tells me that O is negative 2. This time, I'm not going to say equal to 0 because there's a charge on this polyatomic ion. So 2x minus 14 equal negative 2. 2x equal 12. X is positive 6. So this Cr is positive 6 and it dropped to positive 3. So this got reduced. Similarly, let's do for the next one. This one I can see that it is plus 2 because of the charge written on it over here. However, I need to find this Mn. So I'm going to name it as X. Let me write it again. MnO4 negative. So X plus 4 times the oxygen equal, this time is negative 1, not negative 2 like the previous example. So solving for X, we will get X as a plus 7. So it was plus 7 and dropped till 2. So this one also got reduced. So the second and the third. Moving on with the rules of oxidation number. As I mentioned, O is always negative 2. So O is always negative 2. Unless O is in a free element. In this case, O is going to be 0. And there are some exceptions to O. This is an exception. This is another exception. And this is another exception. For my students, I only need you to know this one. In peroxides, O is negative 1. However, for other scenarios, I can calculate O since it's coming with F. F being minus 1, twice O needs to be plus 2. Now, other examples, H is always plus 1. H is always plus 1. This is never going to change. That's the rule. Any free element, 0, the oxidation number is 0. Now, elements like group 1, positive 1, group 2, positive 2, and the rest can be solved. Like, for example, carbon, I'm going to name it as X. X plus 4 times the hydrogen equals 0. So X is minus 4. And so on. Now, the last two examples, the purpose, again, of knowing this oxidation number is to know when they give you an equation which one got oxidized and which one got reduced, or which one is the oxidizing agent and which one is the reducing agent. So let's look at the oxidation number. O, we know it as minus 2. Cu, we don't know it, so we'll replace it as X. Minus 2 equals 0. Therefore, X is positive 2. Now we know. H is always positive 1. N is X. So X plus 3 times 1 equals 0. X is negative 3. Copper being a free element, 0. So the oxidation number of copper reduced from 2 to 0. Also, N as a free element, it is 0. And in here, we know that H is positive 1 and O is minus 2. Now, looking at O did not change, so that's not the case here. O did not get reduced or oxidized in this example, nor the H, because positive 1 remains as positive 1. However, copper oxidation number dropped from positive 2 to 0. That's a reduction. So we say that Cu2 plus got reduced, or I can simply say CuO. To be on the safe side, you just say CuO got reduced. And N, the oxidation number goes from -3 up till 0. So it increased. So N 3 minus, or you can simply say NH3 got oxidized, did an oxidation. One last example. Let's go on the one that we know, -2, -2, -2. Free element 0. Now let's calculate the C and the F in every time. So here, X minus 2 equals 0. So X is positive 2. Now, in this one, I'm gonna name 2x because I have 2 Fe. 2x plus 3 times the oxygen equals 0. So 2x minus 6 equals 0. X is positive 3. Now, I can see the answer from now. From +3, the Fe dropped to 0, so that's the reduction. And let me continue the C for you. I'm going to do the CO2. X plus 2, the oxygen, equals 0. X minus 4 equals 0. X is plus 4. So this one, from +2 to +4, that's an increase. Therefore, CO undergoes an oxidation. And that's it. Thank you for listening.